The objective for this video is to learn to conduct a probability experiment using simulation. A simulation technique uses a probability experiment to mimic a real-life situation. The Monte Carlo method is a simulation technique using random numbers. Step 1 is to list all possible outcomes of the experiment. Step 2 is to determine the probability of each outcome. Step 3 is to set up a correspondence between the outcome of the experiment and the random numbers. Step 4 is to generate random numbers and conduct the experiment. Step 5 is to compute the statistics and state the conclusions. Use random numbers to simulate the outcomes of rolling a single die. Use this simulation to estimate the probability that the side with one spot will land face up. Step 1 is to list all possible outcomes of the experiment. The possible outcomes are that the side with either 1, 2, 3, 4, 5, or 6 spots could land face up. Step 2 is to determine the probability of each outcome. Each outcome has a probability of 1/6. Step 3 is to set up a correspondence between the outcomes of the experiment and the random numbers. An Excel spreadsheet will be programmed to randomly generate the digits 1 through 6. These digits will correspond to the possible numbers of spots that appear on the side that lands face up. Step 4 is to generate random numbers and conduct the experiment. This list of 20 random digits was generated using the random number function in an Excel spreadsheet. From this list, we can find the frequency of the number 1. We will repeat this process, so we will also compute the cumulative frequency of the number 1. We will keep track of the number of cumulative rolls of the die, and from these values, calculate the proportion of times a 1 is rolled. We can see that in the first 20 simulated rolls of the die, the number 1 appeared 5 times. So the proportion of times that a 1 was rolled is 0.25. We know the probability of rolling a 1 is 1/6. 0.25 can also be expressed as 1/4. So there is a discrepancy between this simulated probability of rolling a 1 and the theoretical probability of rolling a 1. The law of large numbers states that as the number of trials of an experiment increases, the empirical probability of an event will approach the theoretical probability. So we will continue this simulation by expanding the number of groups of 20 random digits from 1 to 6. Note that the proportion of times that a 1 is rolled is changing as we expand the simulation. As we continue to increase the number of simulated rolls of the die, we see that the proportion of times that a 1 is rolled begins to settle in around the theoretical probability. By the time we have simulated 1,000 rolls of the die, the proportion of times that a 1 occurs has reached 0.17 and remains consistent at that value for the remainder of the simulation. Step 5 is to compute the statistics and state the conclusions. From our simulation, we can conclude that the probability that the side with one spot will land face up when one die is rolled is 0.17. Note that the theoretical probability of rolling a 1 is 1/6, which can be expressed in decimal form as 0.16 repeating. In this video, we learned how to conduct a probability experiment using simulation.